Alright, I'm ready to go.
Okay.
It's just going to be a plain old live event,
Okay.
which is a little bit disappointing.
Is that different from what you're doing here?
It is...
Wow, you got 5 people waiting. Shit.
Damn.
I'm running it in the chat. We are, what? Switching to a live event?
Yeah.
Okay, launch it, and I'm going to put the link of that in this chat for those who are here.
Can you see it on the, my page?
Check. Winston makes more, right?
Actually, hold on. Alright, should be live. Let me know if you see it.
Okay, let me check. No.
No.
On Winston Makes More, right?
Yeah.
Oh, there we go, live now. Okay, it just popped up. I'm going to post a link. Here I am.
Alright.
I'm going to take this and putting the link in the chat right there.
Yep.
What? I didn't let you put links? Oh, you got to be kidding.
Oh my goodness.
All those waiting.
I guess I should go into that
Yeah.
and post that myself.
Just let people know. Exactly. Let them know I'm not some...
Some rando.
Yeah. Maybe you can put a link.
I don't know. We'll see.
Take a
Damn,
shot.
I'm the wrong. We'll have this ironed out by next time.
We got 3 on here, though. We got 3 watching.
Okay.
For all those watching, just a second, we're informing everybody about our technical
We
difficulties.
have first time live streaming technical difficulties.
new Mr. the Max over here.
I don't know why. Like, I had the stream key set up and everything.
To be fair, YouTube is pretty new to live streaming too, so let's put some blame on YouTube here.
I'm all for that.
Yeah.
All right. So, where do you want to start?
How about some introductions?
Yeah.
I'm sure you all know.
Well, I mean, we can't start it off without saying, hello guys, Winston here. And tonight I'm joined by my friend George LaHav. Why don't you introduce yourself for those
What's
of
up,
you who
guys?
don't know?
George LaHoff here, with the YouTube channel Maker's Best Friend. Like Winston said, good friend of Winston here.
Good is a bit of a strong adjective, but
Yeah, we're buddies, acquaintances, roomies, you know, called several different top names there. So how about we go through some history of what kind of brought this project on, Winston, or?
yeah, so why don't you explain why we're doing this project?
All right, so I don't know how many of you guys have been to Harry Potter World in Universal. They have these interactive windows where you can buy their Harry Potter wands, and what happens is you do a spell from the window, and some magic will happen in front of that window. So those wands cost, on average, like $60 to $100. So instead of doing that, you know, being makers, I talked to Winston here, and I'm making a video on how to make this wand in 3 different types of ways. 3D printing, I handmade one, and then I asked Winston if he could actually CNC one. So today he's going to go through how to actually use Fusion 360 to create the G-code for this wand because it's more complicated than those with basic knowledge. And the interactive part, right? So how do you actually make this happen? Actually have these. You guys probably won't be able to see from there,
I'll
but
boost the size of your screen.
let me see if this is. All it is in the windows of the Harry Potter windows are infrared sensors. So it looks for some type of reflection from the wand. So I got these reflectors that actually stick to the top of the wand, and this will pretty much work exactly like those Harry Potter wands. I'm going to stick it to the top. This was $30, but you get 10 of them. So now I can make 10 different wands for the small price of $30 compared to their $100. So I'm going to be heading out to Harry Potter World this Friday. And then a week after that, I'll try to post a video to show you guys the results of this video and all of these efforts to show how well it works. So did I cover everything there, Winston, you think?
Yeah, and for those of you who don't follow William Osman, he made a hilarious video with the same principles where he basically stuck
really good video.
retroreflectors on trash and hot dogs and horrible things like that.
Literally reaching inside of the trash, picks out a pickle. In the video, he actually steals a kid's wand to show that it works the exact same way. That was pretty good.
So basically, where I'm starting from is a Thingiverse model. Just your run-of-the-mill STL file. We're going with the Elder Wand, a single-piece model. Any one of these would be fine. Sometimes they're broken up into multiple segments, and you just have to stick them together before you machine it. So I have a file already downloaded. So I'm going to go into my model workspace and hit Insert Mesh. I'm going to go with the single piece. This one comes split up into two, if you so choose, if you want to print them separately. But since we're going to machine it from a single piece of wood, we'll go with the single piece STL. I know for a fact that this file, once it loads, is in millimeters. So we'll change that setting, hit OK, and we have our model.
If you chose inches, would it automatically convert it for you?
So let me show you in Meshcam. It shows you, I wish Fusion would show you by default, but you can, the units in an STL are non-dimensionalized. So I have 28 units by 380 units by 28.1 units. And so if it's in inches, I have a wand that's a foot in diameter. If it's in millimeters, it's a little over an inch in diameter. So you need the right, you need to know whether or not those dimensionless units should be inches or millimeters.
All right, that makes sense.
But we're not going to use Meshcam today. So we have a file in Fusion 360, and this mesh has a ton of polygons. Like, if I wanted to convert to a boundary representation, it would say, can't do it. I'm looking at almost 500,000 facets and 10,000 zero limits. So we're not going to be, you could simplify this mesh down to a much lower level of detail. In fact, I'll show that off now, where we can modify. By the way, the mesh workspace only shows up if you have a mesh on your screen, and you have to enable the mesh workspace. It's sort of a beta feature, but once you have that, you can go into a screen like this. You can go into Modify, Reduce, and I'm going to use Windows selection so I can highlight everything.
Okay, cool.
And then I can just drop the face count down to whatever I want it to be.
Wow, that's a cool trick.
Yeah. You could also do it like based on density or tolerance. The problem is if I do this,
removing detail from the.
It is. So I'm going to show you. You can see right now. Let me cancel that. how this model sort of looks like a golf ball.
Yeah, 100%.
And if we want to wait about 30 seconds for this to actually run, if you do the reduction on this model, it's going to come out looking a little blotchier.
Gotcha.
So
For all those watching, feel free to post any comments or questions as we go through this. I'll keep an eye on it as we go through here.
And feel free to direct any criticisms to George.
I'll take all the new comments.
All right, so unfortunately, I only have a Core i7, older generation. So that's what it looks like with a reduction down to 10,000 polygons.
Not too bad, but yeah,
I mean,
you definitely lose detail as you go through it.
You're only going to be able to see so much with like a CNC ball and mill coming at this, and it's going to look a little gnarled, a little more like actual wood instead of like the specifically detailed features, all the divots and indentations. So we're going to go back to the original model, undo mesh selection, and we have our little golf ball dimples back. So, can't do anything with the model workspace for now. We're going to go into the cam workspace, and I'm going to...
Hey, you got a question here, Winston. Did you turn off the history feature before you imported?
I did, but I didn't... It's not strictly necessary because I'm not converting it to a boundary representation. So, if you wanted to make any changes to the mesh, you'd have to turn it off and convert it. But since I'm not doing any operations to this mesh at all, we can just leave it on and just work with the raw mesh. So I'm going to create a setup, and looking at the stock, well, actually, in the setup we need to define what the model is. So you click model, you click your mesh, and now Fusion 360 is aware of the volume of this piece. So now when you go back to stock, it correctly shows like it's 15 inches long, it's 1 point whatever inches in X and Z.
Gotcha.
Now, because we're machining this from real materials that we have to source, you're probably not going to have material that's exactly 1.14644 inches tall. So I'm actually going to use a fixed size stock box, rounded up to the nearest 0.5. And so now my bounding volume of my stock is 1.5 inches thick, 1.5 inches wide. You could machine this from like a 2x4.
Yeah, for sure.
So this makes it actually machinable instead of needing.
And you would just plane it with the CNC, right? I'm assuming.
Yeah. So you do a facing operation or an adaptive clear. I'm gonna just not do any of those operations, just because like facing down to an arbitrary height doesn't really help us much, because there's still, if say we do a face operation over on the right here, I mean, you'll bring the cutter down to the surface of the piece, but all the way on the other side, you still have so much more left to machine out. I'd rather just use one tool path.
Yeah, makes complete sense.
So I've got my stock. I'm actually going to put a little extra on X and Y, and I'll show you why in a minute.
Quick question out to all those who are viewing right now. What type of CNC machines do you guys have, if you have any? If you don't, which one are you guys looking out to get?
Look at you, George, engaging the audience.
I like to talk to people. I'm a people person.
I know you do. That's kind of why I keep you here. So we've got our setup. We've got our mesh encapsulated in a stock volume, and I'm just going to start off with an adaptive clear. And so because this is going to require two-sided machining, I'm not going to cut all the way through. Like if I just, what John Saunders of NYC CNC likes to do is just start off with the default settings and see what happens. And so that's what I'm going to run through now. And it's just going to show you how the toolpath is generated around the piece. So all of the 3D toolpaths in Fusion 360, they're what you would call model aware. So they'll automatically work around the volume of the piece you're trying to machine. That's why I can just hit adaptive, hit OK, and it knows to go around this piece.
Wow. Look at that.
So you'll notice with this, the adaptive goes all the way to the bottom.
Yeah.
And if you're trying to if you're trying to machine this from both sides, you're not going to be able to hold this wand. You're actually going to need tabs, and without a contour operation, you can't really do that. So we're actually going to have to put in our own tabs in this model. Follow?
Gotcha.
So I'm actually going to go back into the model workspace. I'm going to pick a face that is parallel to the axis of the wand, and I'm going to start drawing some circles. So I'm going to put...
You got a whole bunch of people with Shapeoko 3s over here. Well, we got two. One of them has two of them, though, so... I'm jealous, Frank.
He's started...
So,
he's got the legacy machines.
he's got the Shapeoko 1, and now he has two Shapeoko 3s, and then Mad Drago got a Shapeoko 3. And you guys are doing it right.
So what I'm doing now is I'm just drawing a couple circles that I'm going to extrude into basically tabs.
Oh, that's interesting. Okay.
And so you're going to have to sand these off. It's going to be a little more effort, but you have a lot more control over where this piece is supported.
Yeah.
So I'm going to stop that sketch. I am going to...
Yeah, I'm moving up. I didn't even know that you could place your own tabs. I thought that was that automated one from before. So
it's a nice feature. So I'm going to extrude all of these that I just drew. And I'm going to do it symmetrically. So that means it's extruding from both sides. Distance, let's see what 1.5 inches looks like, and let's look at what that looks like with the wand. So that's how the wand will actually be supported.
Gotcha.
So we'll go back into our cam workspace. Let's, so since we're going to flip this, we don't need to machine all the way through to the other side. We're going to come back with a second adaptive and do that then. So I'm actually going to change the height of this to only come up to 0.75 inches from the bottom, which, as you can see, is our midplane.
Right at the midplane. Nice.
And like you'd of course go and you'd modify your feeds and speeds to get like the right settings for cutting wood. Maybe do shallower step downs on your primary passes, just so that you're not putting as much stress on this, because this is going to be pretty thin.
I was going to say at the tip of it, it's going to be pretty.
Yeah. So the settings you'd want to change there are in the passes tab. Your maximum roughing step down. That's your these two big steps here. First pass, second pass, where it's taking away most of the material.
Yes, you want to lessen that right at the tip.
That is the first pass. These are the secondary passes, where it comes in and just refines. So we could do maximum roughing step down of, I don't know, let's say 0.07. Let's be gentle. The fine step down is usually 10% of it. I don't really care right now. We'll just do like 0.03. And so now you should see that the major layers that this goes through are a little closer together, and it also takes longer to process, though. That's the downside.
I was going to say,
that's why
360 thinking here.
Yeah, when you're just looking to see like whether or not it understands what the model is and if it's going in the right place, just stick with big chunky step downs and make sure it gets the broad strokes right, and then you can come in later and refine the model. So,
quick question: how long does your simulation time look like right now with all of that?
Not great. Not bad.
Oh, it's not terrible.
No, that is terrible.
Is that hours or minutes?
That's like 2 hours and change.
Oh, that's
So
hours. Okay.
that's because a
That's
lot of
rough.
my settings in the feeds and speeds are not set.
Okay.
So I would actually be cutting this probably at like 90 inches per minute. You could probably go faster. 40 lead in, 40 lead out. My ramping speeds, something like that. No flood coolant, and that should bring down the cutting time by like a factor of 3.
Okay.
And then also for a lot of these passes, I would probably be a little more aggressive. There are. Here, let me talk about tool engagement. So when this is coming through, and it is cutting,
Yep.
it is cutting with about 40% of the diameter of the end mill. That is the radial engagement, which you can change. It's called optimal load. So I could bump that up to, say, maybe 0.18 inches, and it would use a larger portion of that diameter. And so
Yeah,
it takes larger step overs. You can see there are a lot fewer lines here. And
Wow.
if you, once this finishes calculating out, if you simulate it, you can see
Yeah, you can definitely see.
it's taking
It
a
went in a
much
lot
bigger
more.
bite. And so that helps reduce the machining time. So now we're down to under an hour.
That's a nifty trick, Winston. I like that.
So yeah, that is the roughing operation for the first side. And what that leaves you with is a really chunky mess. I'm going to hide the toolpaths. That's what it's going to look like after that first operation. And
Okay.
so what you need to do is come back with a second end mill, a smaller one, a finer one, to sort of refine all these features. So we're going to
Yeah,
do
that
that
makes
with
sense.
a parallel toolpath. I usually just throw this on everything. It's my lazy go-to toolpath. I'm going to change it to a 1/8 inch ball end mill.
Okay.
Change all these feeds and speeds because it doesn't really matter, but I'm probably going to machine this tomorrow.
Sounds like
no
a plan.
flood
Right time
coolant.
for my Harry Potter trip.
And
How many
so
of you guys have been out to Harry Potter World, if anybody? We'll see if that's a little bit of a so you can keep going. Oh,
so-
wait, you got a question here,
yeah,
Winston.
yeah, I see.
When working with it. Oh, you got it?
So it really depends. You can leave a lot more stock for purposes of stability. The more stock you leave, the stronger the part is. And it also depends on what you're coming at it for the second operation. So I'm coming at this with a parallel toolpath with a very small step over. And what that does for me is I'm going to simulate both of these toolpaths together. I'm going to go to the end of the adaptive and then just play it back from the parallel toolpath onward. So right now I have, I think it's 0.02 stock left. And as this end mill comes through, you can see, oops, I
Oh,
wrote
boy.
it. It's got to recalculate everything out. The ball end mill isn't really engaging with all that much material. I can't
every
dynamically
time
scroll
you
back and
move.
forth. I'm just going to slow this down. So 0.02 is perfectly fine for something like this, just because there's really not a lot there to touch. So as it shifts over 0.0125 inches, it's just nibbling away at what's left. So 0.02 is fine. You could leave more if you're worried about, say, the supports. Now, one thing I'm noticing here is that this parallel toolpath isn't quite touching all the sides. Why is that? I'm going to set the same settings for the height.
Pretty cool, Mike. You're getting Shipoko 3 XXL. Gonna
I
do some
wish I
big
had
work
the
with
room for that.
That's pretty cool. I
Silhouette.
can't say I don't have the room. I got the Mazda, but I wish I had something with a little bit better tolerance.
Um,
Figure it out there.
yeah, so what I was doing before was I had the option for silhouette. So it looks at the silhouette of the piece, and it was putting the tool on that boundary. So when you look at where the tool is, it would never leave the silhouette of the piece.
Okay.
So if I show the toolpath, hide the stock, where's my tool? That tool, the center of that tool is always staying within the silhouette of that piece.
So you're never going to get the edges like that?
Yeah, because if it's stopping right here, it can't get around to the side. So you have to change the setting to allow it to just push outside just a little bit more.
So when you do that, is it always going to be outside the boundary, or is that just
it allows
allowing
the tool to push a little further, and that's why the
But
toolpath
it'll still
extends
go
past
over
it.
the. Okay, perfect.
Yeah. So you still get full coverage, but now the toolpath comes all the way down to our halfway point.
I'm surprised that's an option. You think you'd want that most of the time, but
It
I
depends
guess
on how
they
you
just
want
keep it
to
complete.
contain the piece.
Yeah,
All right, so we got.
that's good. They give you complete controllability like that.
I know,
So that's
but that's also why it's so daunting for some people to pick up, because
Yeah.
you got to make heads and tails of what everything does. And
Trust me, I'm gonna have to watch this video like 20 times just to make it myself at some point. It's pretty cool though.
So we're looking at about an hour to cut the first half. All right. So let's create a setup for the flip side operation. I'm actually going to just duplicate our first setup. We'll call that the, gotta capitalize the S. The right side up setup and the upside down setup. And in this setup, the only thing I really need to change is the model orientation. So I'm going to pick a z-axis and an x-axis. I'm going to pick the original ones.
Mm-hmm.
And I got to think about this. So when you flip a part over, you got to make sure the orientations all match.
That's what I was wondering, how you actually do that.
So I actually have a convention because I have the Shapeogo XL, which is wider than it is deeper, that my piece should always be pointed in the X direction.
Yeah, makes sense.
We're going to go right side up. Z-axis is proper up. The X-axis, let's see. I'm picking X-axis. Why am I picking Y? Whatever.
Yeah, it works. That's so the. Oh, nice.
My stock is.
There you go.
No, I gotta manually set this.
Gotcha.
17, 3, and am I right side up? I am not right side up. There we go. So now X is pointed to the tip of the wand, and Z is straight up. And I'm also going to set the origin to the top. So when you come in and you probe for your Z height, that's where it'll go. I'm going to hide the origin again. So that's how I'm setting up my origin on this piece. X,
because
positive
specific
X.
for your machine, right?
Yeah, positive X, always towards the tip. And that's the convention I'm going to keep just to keep things straight in my head. I'll regenerate that toolpath later. So on the flip side, we are going to...
Thanks a lot, Mike, for watching. Thanks for coming out.
Yeah, thanks, Mike. Z-axis still is going to be... It's actually got it correct right now, but I'm just going to pick that Z-axis, pick the X-axis, and change my stock again.
Yep.
Oh, why did I say 8? Let's go with 3. And X is backwards, so I'm going to flip that. And on the flip side, we have X pointing towards the wand tip.
Yep.
So we're still keeping with that convention. And I actually need to set the origin to the top of the stock. So, upside down side looks like this. Right side upside looks like that.
Okay.
So they're the exact mirrored opposite. And
Yep.
I'm wondering if I regenerate these tool paths,
Yeah, if you could.
because everything about the cutting parameters is the same, and it just needs to know what part of the model it needs to work with.
Yeah, it should just be a mirror opposite, right? So
Yeah.
maybe you could.
So you can see that adaptive does the bottom side, and then this
Yep.
adaptive does that
Oh,
side.
wow. Look at that.
So you can basically just use the same settings, same toolpaths on the same model. And just by changing the orientation of which side the tool is coming from, Fusion will know just how to cut it. And it's basically how I did the 5-axis stuff. You just change your setup
That's how you made the.
to say hey, the tool should come from this direction, and just let Fusion figure out where the tool should go.
That's very impressive. And you actually said, right, for the 5-axis, that was a one-shotter for you. You didn't have to redo it. You just
I
you
kinda
nailed
got
it
it on
the
the
first
first
time.
shot. Let's not brag about that
Yeah, man, that's
as much as I want to.
that's pretty impressive. Probably would have taken me a couple
Couple
Well,
crashes. Yeah.
This is why they don't send me 5-axis machines.
I'm sure there are other reasons. So
let me ask you a question at this point.
Yep.
So when you actually put this, and let me know if I'm just jumping ahead, when you actually put this, lay out the wood in your machine, right, and you're flipping it over to do the other side, is there something you do personally to make sure you're aligning it correctly
so
back to the machine?
doing two-sided machining without indexing pins is basically impossible. So what I like to do is when I lay down a piece of wood on my machine, I mill 2 holes on either side. So in this case, I'm just going to draw an example of where these would be.
I'm happy to hear that, because that's exactly how I thought you'd do it. So got one thing right there.
Yeah. So I would want to put 2 holes about there and there. So just going back into the cam workspace.
And just drill that all the way through, right?
Yeah, and I would use the machine to do it. And then on the table of the
exactly.
machine, I would do the same thing. So for the, I would,
Into
what
the
I do when I'm
actual.
lazy, I'll just create a sketch with 2 holes of whatever distance apart,
Yep.
and then just make a drilling operation based on that. It's just like 2D pocket. Actually, I gotta create a setup. But I use the same tool path to drill these 2 holes in my wasteboard as I do on the stock for this before I start machining anything else.
And you just put the pins in there, hold them to place, and that way you can. That's
Yeah, and
That's
that way
cool.
they're in the exact same spot.
pretty cool.
So there's one more thing, one more little wrinkle about this toolpath that doesn't quite work, is right now we're cutting away a ton of material that we don't need to. So ideally, you'd sort of just follow a contour around this piece and
Yeah.
cut only that. But since we didn't convert this to a boundary representation, I can't just go into my model workspace and say like, oh, like pick that outside contour and offset it about 1/4 inch. So I'm going to have to draw my own little sort of, it's called a containment boundary around
okay.
this piece. So I'm going to sketch on this plane.
That way you can tell the outline of the wand, just
Yeah,
like
yeah,
we did
yeah.
in
So I'm going to say
the tolerance test.
that is, all right, so I just need to make sure I have at least 1/4 inch of clearance between my part and my wall. So that's about good enough.
Okay.
And
So you don't have to mind your tabs then.
correct. I'll show you what it looks like.
Cool.
I'm going to draw a quick little line here as my mirror axis. Select just that line, hit X, or right click, go to normal or construction, turns into a dotted line. So that doesn't count. But for everything else, I just double click to select that contour. I will go to sketch, I will go to mirror. My mirror line is that little axis I've made. And we have a
That's
closed
fantastic.
contour. So now when I jump back into the cam workspace and I pick this adaptive, what I can say is, with the machining boundary, pick selection, pick that contour, and I'm going to keep that tool inside that boundary. This might work, this might not. Depends on whether or not I left enough margin, like at the end. But we're just going to find out. Let's see what it cuts.
Yeah, let's see how this looks.
All right, staying in the lines, but it's getting all the way around it, and it got the end. Perfect.
That's fantastic.
So the amount that this is machining,
wow, look at this.
A lot less.
Yeah, that's a good move.
Gets to the bottom, and let's look at what the machining time is for this. Total machining time, 37 minutes.
That's not bad
at all. So we saved
all.
like 20 minutes by machining away less material.
I really wish I did that when I did the tolerance sense for the nozzle, because I was milling out everything in a large square around it. It was so wasteful.
Yeah, mistakes were made.
Yeah, more than one.
So, what I sometimes do with a parallel toolpath is, just because of the way the end mill is going to come over this, it's going to leave like sort of concentric rings all the way down. I'll come back with a perpendicular pass, and so the toolpath looks like it's hopping over this in a ring-like fashion, then axially. So it comes forward and backwards. It's probably not the perfect toolpath for this, but when you really don't
It'll be pretty
care,
detailed though.
And you want to be thorough with your coverage, like you want this end mill to touch every part of this, it works pretty well.
Yeah, that looks fantastic, man. Hey, you think we're gonna get some snow tomorrow or what? All those in the
I hope so.
Central, eastern area.
The latest forecast only said it would be like an inch.
I'm seeing 3 inches, man. You're checking around 4. Well, actually,
you're closer to the shore.
So. Yeah, I get a good amount normally.
Yeah. So this is the perpendicular pass, and just by doing all of that, you can get a pretty good surface finish. So that's with a ball end mill. This is with a 1/4 inch end mill. And so what I'd probably do to machine these, I would post these separately.
Okay. Like 2 different files, do one then the other?
Yeah, so I could run, because I got to do a tool change. And unless you have something with a tool
like
library or an automatic tool probe, you got to like just stop the machine, change out the tool, then restart it. So I would actually probably post these as a separate file. And naming is also a big thing. You got to make sure, be methodical. So this is side A, 1/4 inch operation.
Gotcha. Hey, for all those watching, if you guys are interested in, future live videos, feel free to post as we talk here because I know there's a delay. So, in case you guys miss you at the end, kind of keep that out there and open for you guys. George is blonde. I like the sound of that.
And so this is still side A. This is our 0.0125 thou operation. And basically just do the same thing. This will be side B.
Okay.
This side we need to set the containment boundary as before, but that's basically all there is to it.
Yeah, that's fantastic.
The
That
spacing
really is.
of some of these tabs you have to play around with. Like the tip of the wand might be just a little too fragile. That's like it's not a lot of material there.
And even the tabs for that might be kind of hard to machine
Yeah, I mean,
sand
you're gonna have to come
right?
at this. You're gonna have to come at it with a Dremel and just use a little cutoff wheel.
Like
take these
a
off.
filer at the end of it all.
Yeah, and then just sand that down.
Yeah.
And so that's actually a reason why you might want to leave less stock, so that the parallel toolpath just has less work to do. But it's a fine balance you got to figure out for yourself. Oh, that's interesting. Looks like the parallel toolpath doesn't respect the tabs that we have. So let's
see it going through it, huh?
generate that toolpath. So these are the things. This is why you look at your toolpath like 15 times before you actually run it, because I've missed things like this before. And so geometry, model surfaces. It should definitely pay attention to the wand, but it should also pay attention to our tabs.
Okay.
And so now, when it goes to the toolpath, fingers crossed, it will go around the tabs. It's actually machining the tabs too, like all the way out, which we don't really want it to do, because the adaptive hasn't actually cleared that area. So if it's coming in this area over here, it's actually just going to be ramming straight into uncut wood.
Yeah.
So we want this toolpath to actually respect the same containment boundary we had before. So tool inside boundary.
Nice. That makes complete sense.
It's still going to machine the tabs, but that's fine. It's like a couple extra seconds of time. So now that's what it should actually be.
That looks pretty good. Yeah, I see that. I see the little subtle difference.
So there's still a lot more you can do to optimize it. Like I could make a tighter containment boundary that cuts so that you're touching less of the tabs. But for the most part, that's all there is to it. So I'm going to run this
Winston,
tomorrow.
You actually made it. You're so good at explaining this that I actually feel like I could try to do this myself, which is a lot. It's saying a lot.
You should try it though, because all of these options that are in here, you only really figure out through trial and error. Like the feeds and speeds, that's self-explanatory. But once you start getting into all these options like slope, like rust machining, like only by like just trying around, poking with the settings, are you really gonna get a feel for what they're used for. Like slope here, I could say I don't want you to machine the really steep parts, so like stop at 75 degrees. And when I come through here again, it's going to probably avoid some of these walls over on this side. Let's see what it actually does. There's some places like right here
in the middle right there
that it's avoiding. It's not coming all the way down and hitting it from the side. It's probably not the most dramatic example I could have come up with, but
no, you could tell for sure, especially in the middle of some of the details there, skipping out.
Yeah. So I'm probably going to run this tomorrow after work, and I will let you know how it comes out.
Thanks. Thanks a lot, Winston. It's going to be pretty fun to bring out there and test this out with everything else, obviously.
And actually, if the tip like just breaks off a little, you're actually going to have to cut it off anyway to stick on your retroreflector. So it shouldn't be a problem. Yeah,
I don't think that'll be a huge problem. I need to stick these guys onto there somehow. Well, this actually comes with double-sided adhesive, so that shouldn't be too big a problem.
I wouldn't trust that adhesive. I just use a little bit of super glue.
I was going to put some super glue. Yeah, I'm going to use super glue with that.
just for backup. You can't trust it.
Michelle's still questioning my me actually making this happen, so I got to make sure it happens. I can't lose that battle.
You can't let her down, or you can't let her be right. That's more important.
Can't let her be right. I think is the right. Thanks a lot, man. That's pretty helpful. How about out to the folks watching out there? Any questions, comments? We're looking to find out how this was for you guys, so we can figure out our future live streams, figure out what's useful for you guys, and what you guys are looking for from us. Mainly from Winston while asking questions.
Well, I mean, eventually I think we can expand this, and you can talk about topics that you're more familiar with, like 3D printing, like that little laser cutter you have. That's pretty cute.
It's cute. I was thinking about going into some Raspberry Pi stuff. I have some ideas for the folks out there that might be still applicable to CNC and making with Raspberry Pis. Well, we'll talk offline and kind of shoot some ideas between the two of us and kind of figure out where we'll go from there. But
one other thing I like to do just before we sign off is so you could see that this toolpath, it has a helical ramp into the material, so it comes down in a spiral, so it's not just plunging straight into the material, but it's actually pretty slow. Like when you're cutting aluminum, that's really helpful. Wood, not so much. So what I like to do is you can either take it out completely and just go with a plunge operation, or what I do is just make a more aggressive helix. So it
that's pretty
10 degree, and I start it from the top surface of the material just a little bit closer, so maybe 0.02 inches.
Okay.
So it starts much closer to the surface.
Yeah, look at that. Oh, that's cool.
It takes out a couple seconds for each plunge, which helps out a lot in the long run.
That's pretty fantastic. Hey, you got a question out here.
Yeah.
From France.
So Meshcam is good because it doesn't give you a ton of options. You click roughing pass, you click finishing pass, and that's basically all there is to it. You can do waterline finishing, you can do parallel finishing. I'll pull it up for people who haven't looked too closely at the interface before. And so, let's see, is my orientation correct? Z is up. You can define your stock to be fitted to the geometry, close enough. Any supports you might want. It's a little slow just because of the size, the number of polygons. You can set your retract height, your program 0, and when you generate a toolpath, these are your options. Roughing, yes or no, and then finishing, parallel, waterline, and just a little pencil trace around. And that makes it really straightforward and easy to use. The problem...
Less controllability, huh?
Yeah, so when you're doing wood, that's fine. These toolpaths are very basic and straightforward. It doesn't do any of the ramping or adaptive clearing. In wood, that's fine. But when you're starting to do metals and you need more control over how the tool enters the material, then you start to run into limitations. And I'm going to do a video in the future about why adaptive clearing is awesome. But it comes down to the fact that, remember our radial depth of cut? How we could say we only want the tool to engage a certain use a fraction of its diameter. You can't really set that as well in other programs that don't have adapted toolpaths. Because what happens when this cutter runs into a corner, it rams straight into the corner, and all of a sudden you have a much larger circumference of that tool being engaged by the material. It changes the stress on the cutter. If your machine isn't rock solid like a Haas or a Tormach, it can cause deflection. It can cause chatter, and so that's why being able to control just how much bite your tool has gets important with higher level machining. But for meshcam, wood, plastic, it's fine. But it's just having that amount of control over your tool path that makes it much more valuable for complex stuff. Does that answer your question?
And look at, did it add the tabs there itself, or did you do that, those red tabs?
So I added those tabs.
Okay. I missed it.
The other problem with meshcam is that you don't have real-time feedback into the generation of the toolpath, so I don't know if it's frozen or it's going to like pop out with the toolpath in the next 5 seconds.
Yeah, the top's not responding. You gotta.
What is the purpose of the ramp plunge clearance when cutting into metal? Default value is really high. So what he's talking about is these heights for your retract height, your top height, feed height. It depends on whether or not you have clamps you need to avoid, usually, but I will just set these a lot closer, just so that my tool has less distance to travel. So you can see the yellow tool paths. That is when it's just plunging straight up and straight down. Depending on what kind of tool paths you have, there may be a lot of them, and so by just shortening that retract height, you can save a couple seconds here and there. But unless you have any conflicts or like your material's uneven, you can be pretty aggressive with reducing that height. I will say that for some material that I've cut, that like if the wood is a little warped or wavy and you have a pretty fragile end mill, I've seen like bowing of up to like a 1/16 of an inch, and if you don't retract past that, you could just scrape your end mill against the top of your material or just crash it. So it's, as long as you're comfortable with the amount of clearance you have, you can shorten up that retract height.
Yeah, that's fair. I noticed with the Maslow that I really wanted to reduce the retract height by a lot.
Yeah, so
it was
with
going
the
to
Maslow, you don't have clamps, so you don't have anything on the top surface of your material, and also your sled helps you account for any sort of unevenness in your material.
Exactly.
So in some ways, the Maslow, there's less to think about.
Are you about to compliment the Maslow here, Winston? Is this coming?
I was going to say it's like having training wheels on.
There you
go. Just take it how you will.
I'll take it as a compliment.
All right.
Maslow, we're going to make great things. You'll see. It's coming.
I gotta come over and take a look at that machine.
You definitely do. Maybe when I'm gonna upgrade the design, that'll probably be better.
Okay. Yeah, get the configuration to the latest and greatest, and I'll come over and maybe we'll make that Adirondack chair project of yours.
Yeah, that's a good idea. Let's do that. That'll be, after a little while, they'll come back and visit some other projects, but that sounds good. Cool.
All right. Well, if no one else has any questions, I think this is a good place to wrap up.
Yeah, this has been fun on my part. I hope it's been helpful to everybody watching. All
right.
Good questions. Got different people coming in and out throughout the entire night, so that's pretty good.
Yeah, I had fun with this. Let's shoot for 3 to 4 weeks. We'll try again.
Yep.
Find a new topic.
Sounds perfect.
All right. Cool. Well, thanks everyone for joining in, and if you have any other questions, shoot me a tweet. YouTube message. Feel free to check out George's videos on his channel. I'll put a link in the description after this post. And see you with another CNC related project video in a week or two. See you guys.
See you guys later. It's been fun.